Hi, I'm Martin Davies and welcome to Helix Smelt. I've worked on Helix solutions for the last few years now, and I've also had the opportunity to work with companies throughout the world to provide consultancy on their own Helix implementations. So I've seen a variety of different projects, some good, some bad, and I've also seen the emergence of some bad practices which result in a negative impact on your Sitecore solution. So if you're a Sitecore developer who's worked on a Helix solution, then this is for you. Or if you just generally have some interest in Helix, then great, welcome aboard. If you're not too familiar with Helix, then don't worry, I'll get you up to speed. So a little bit about me. I'm a solution architect at Kaggle. I've been working with Sitecore for around about 7 years now, and I've been an MVP for the last 4 years. I'm an avid blogger. I've written a lot about Helix, so if you enjoy what I'm talking about today, then go ahead to my blog and you can dig a little bit deeper. As I've mentioned, I'm a battle-hardened Helix developer, so all the scenarios that you'll see today come from the real world in the wild. So, for those who aren't that familiar with Helix, let's take the whistle-stop tour. So Helix is Sitecore's official guidelines for creating solutions. It's a modular approach, and it's designed to get away from that big ball of mud approach that many developers take. I'm sure that you've seen in your time as a developer solutions that were built 5 or 6 years ago, and the development team who built it are long since gone. Everyone who now works in your company doesn't know what the code does, and they're afraid to touch it in case they introduce new bugs and break the whole site. This kind of exponential growth in the cost of change over time is what Helix is really designed to combat. So as I mentioned, it's a Helix. The Helix approach is a modular structure which is split into 3 layers. So let's start with a feature layer. That's down the center there. This is where the bulk of your code lives. It's divided into discrete modules that, for example, deal with domain concerns like products, but they may just be general things that you might find on a site like FAQs or search. Supporting that feature layer is the foundation layer. This is where common code that's used by multiple feature modules live, and also provides a means for some cross-communication between those features. The features themselves shouldn't depend on each other, so we really need that foundation layer to provide that common communication. Then we have the project layer. This is all about assembling a cohesive application from your different feature and foundation modules. So in my example here, I've got website 1, website 2, website 3. Each of those websites may cherry pick from the different features and foundation modules to create their own cohesive websites. So there's a lot more to it, and if you want to really get into the detail of Helix, then you can go to the helix.sitecore.net site, where the official documentation for Helix. But really, that's enough to get you through today. So now you know what Helix is, but what is a Helix smell? Well, this is something that I borrowed from Code Smells. This is a term that was coined by Kent Beck in the book Refactoring. He describes it as a surface indication that usually corresponds to a deeper problem in the system. It should be quick to spot, that is to say it's sniffable, and it needs to require further investigation. So notice that they've fallen short of calling this anti-patterns, they're calling it smells. And the idea is that it indicates a problem, but it does need to be investigated further to see whether it actually is a problem, needs action to be taken. So in the refactoring book, we see that each code smell, and there are 25 or so identified, is given a description, a name, why it tends to occur, and how to fix it. So for example, we have things like primitive obsession, feature envy, and the lazy class. Now, the idea here is that by giving these different smells names, then as developers we have this common vocabulary to discuss the problems that we see in our code, and it's really just a shortcut for us when we're discussing them. So let's get into these code smells, and I want to start by looking at Sitecore Habitat. Habitat is the official Helix demo. It's built with all the best practices of Helix using the principles and techniques, and it's a really good resource if you're learning about Helix. As a new Helix developer, you can look at that site, see how it has implemented the different principles, and really learn from it. Also, if you're an experienced Helix developer, then you'll probably find yourself referring back to Helix. If you've got a problem that you don't know how to solve, chances are it was already solved in the Habitat solution. So it's a really good, helpful reference. Take a look at Habitat on GitHub if you want to know more. But Habitat has a dark side, and something I do see quite often is that developers, when they're starting out with Helix, will take a look at the Habitat site. They get a feel for the way it's structured and how it looks, and that's where the learning ends. They don't put the time or effort into really understanding how the principles that underpin Helix have led to the way that Habitat was built. And that leads us to what I would call our first Helix smell, the Habitat cargo cult. The idea of cargo cults was emerged after the Second World War. The idea was that during the war there were troops stationed on islands in the South Pacific. Occasionally they'd get cargo drops. And the indigenous people of those islands would see that this was happening. Of course, after the war, the troops left and the cargo drops stopped. But not realizing why those cargo drops were occurring in the first place, the indigenous people of the island took to creating elaborate mock-ups of aeroplanes and airstrips in the hope that the cargo gods would deliver them more cargo. When it comes to software development, I would call a cargo cult an occasion when a developer blindly follows a set of rituals in the hope that the benefits will just manifest themselves without really understanding what they're doing. And that's what I see a fair bit in Habitat. Let's take a look at some examples. So, one example that I see quite often is that people copy code or entire projects from the Habitat solution in their entirety. So, what that ends up with is that you have redundant code in your solution. There may be that, say, Habitat has extra fields or extra logic that you don't need in your solution, but because you copied it wholesale, it's just there and there's nothing you can do about it. Another thing that occurs is that you might not meet the needs of the users that you have with the Habitat code. You know, if you copy it wholesale, then you're not really going to get an exact match of what they need for their requirements. Another example is that if you need to extend that Habitat module, then you may end up working around that Habitat code. No one wants to do that. It would have been better if you just started from scratch and created the module yourself. So some people don't copy the projects or the code in entirety, they just copy the style without actually using the principles. That's almost just as bad. You get all the overhead of working with a Helix solution, but you don't really get any of the benefit. And in my experience, this ends up just leading back to that big ball of mud code that Helix was designed to avoid. So if you're involved in the Sitecore community through social channels, you may have seen this hashtag. Habitat is not a starter kit, and this is really the community rallying against this Habitat cargo cult. It's really no good. So let's move on. We need to look at a few more of these Helix smells. And the next few are kind of all related to each other. This is this kind of basic diagram that I showed earlier about what we tend to see when we're talking about Helix. It kind of isn't representing Helix too accurately, I don't think, because I think this is what it should look like. That feature layer in the middle really is the bulk of your code, and the foundation layer and the project layer are just there to facilitate those features. So this is probably what I would say is what the diagram really should look like. So for these next few Helix smells, I'm going to introduce a scenario. We've got two features, products and blog. The product links in the products feature will need to have a specific kind of URL. So they're going to be product $ID equals the product ID. We also have a blog feature, and the blog is using a wildcard, which means that there may be hundreds of different blog posts, but we need to represent them all at the same kind of level within the URL structure. So we'll have /blog/* as an item in the solution, and each of our URLs will conform to that format. Now, if you've been working with Sitecore for any length of time, you've no doubt ended up creating a custom link provider for this kind of scenario. So how might we represent this? This is what the code might look like if we weren't working in a Helix solution. You can see we've got our class that inherits from link provider. We're overriding the getItemURL method of the link provider. And you can see in there we've got two if statements. The first if statement is looking at whether the item that's being requested is based on a product template, and then it's applying that query string logic that we talked about earlier and returning the string if it is a product. The other if statement is looking at the blog template. If it's based on the blog template, then we apply that wildcard logic using the Sitecore wildcard module, and we return the string. If it was neither a blog or a product, then we just return the base getItemURL method from the default link provider. So how might we map this code onto our Helix solution? We've got our two features here, blog and products, and we could say that the custom link provider is giving us common behavior between the two. So our initial reaction might be, okay, let's put it in the foundation layer. Now, hopefully you can immediately spot a problem there. I said earlier that the dependencies in a Helix project should go from project to feature to foundation. And you can see the lines here are going in the wrong direction. This is because our link provider is dependent on the blog and products. We saw that it was referring to blogs and products. It was referring to some product constants and some blog constants. So this was inevitable in this approach. You could say, okay, well, if I need to change the direction of those lines, then maybe I can pull those product constants and blog constants down into the foundation layer into their own modules. It might look something like this. So the foundation layer now has its own blog and products foundation module. So all those constants were put in there. Our link provider no longer depends on the feature layer, which is great. But this, hopefully, I hope you can see that this looks kind of weird, and it is weird. This is really coming back to that big ball of mud approach, and it's really not something we want to be doing. So this leads us on to my second Helix smell, which I called the fat foundation. So in the situation of fat foundation, we have a foundation layer module which contains a conspicuous amount of concrete code. We really want to be avoiding that because it makes our whole system a bit too inflexible. So let's go back to the drawing board. We've got our blog and products features. Maybe we could add our custom link provider to the project layer. Okay, now the lines of dependency going in the right direction, that's a good start. But now we have this logic in the project layer, and we don't really want that. As I mentioned earlier, that project layer is literally about assembling a cohesive application out of the feature and foundation layers. And having too much logic in there just makes it inflexible. So we really don't want to go in that direction. This is what I call the fat project. And I describe the fat project as a project layer module containing a conspicuous amount of logic. We don't want to go there. So we've got a problem on our hands. This is the code that we looked at earlier. And there is actually a problem that we haven't discussed yet, which is that let's divide this code up. We've got these two if statements. One's dealing with the product details. The other is dealing with the blog details. Now, right now we've only got two features. In the future, we might get 10, 20, 30 features, and all of them may need their own custom strategies for producing links. And guess where that code's going to go? It's here, and more if statements, and this class is just going to grow and grow and grow. I call this the unstable foundation. This is a situation where the foundation module contains code that needs to change frequently. Remember I said that we have lots of different features and project modules that depend on the foundation layer. Well, if your foundation layer code is changing frequently, then you run the risk of introducing bugs and side effects throughout the system. Nobody wants that. So I've talked about the principles that underpin Helix quite a bit already. Let's see if we can look to a couple of those principles to help us solve these problems. So the first principle is stable dependencies. The dependency between software packages should be in the direction of the stability of the packages. That is, a given package should depend on more stable packages. That's pretty dense stuff. Don't worry, I've got you covered. I've got a translation. So in Helix, this is what that means. Every foundation module will probably have lots of dependent feature and project modules. If you make changes to those feature modules, they can have major side effects. So you really do need to make sure that the foundation modules never change. When you're adding code to a foundation module, you need to say to yourself, will I ever need to change this file again? If you do, then you may have a future problem on your hands. So that principle is telling us that we need to make foundation modules that never change. There's a complementary principle called the stable abstractions principle, which gives us some hints about how we could approach that. So here's the stable abstractions principle. Packages that are maximally stable should be maximally abstract. Unstable packages should be concrete. The abstraction of a package should be in proportion to its stability. Again, don't worry, I've got a translation. In Helix, that means to reduce the likelihood of a foundation module ever having to change, we need to introduce dependency inversion techniques. We need to abstract out the parts of your foundation code that might be responsible for changes in the future by pushing it up into the features. Let's see how we might apply that to our problem. So here's that code again. We've got those 2 bits of code which are responsible for change in the foundation module, and we, like I said earlier, that may grow and grow to the point where this code is huge as more features are added. So what can we do here? Well, this being Sitecore, I'm going to fall back to an old favorite, the pipeline. So let's take a look at our new link provider. We've got the get item URL method again, but this time all that logic's been removed. We've got this args item, which we're passing into a pipeline named resolve link. Now each of the steps in that pipeline are going to provide their own logic to do with resolving links, and if we have a URL at the end of the pipeline, then we can return that. If not, we'll fall back to the base functionality. So let's fill that out a little bit. We've got the product link processor, which, if you see, has all that logic from earlier related to resolving a product link. But now we're actually setting the args URL instead of just returning it. There's an equivalent for the blog, which is applying all that wildcard resolving, and we're setting the args URL. So at the end of this, we've now got a diagram that looks like this. We've got our now newly abstract version of the custom link provider, and we've got 2 features that depend on it, each adding a processor to the pipeline. This solves our problem, I think. So these principles, and there are 4 more, 6 in total, come from a book named Agile Principles, Patterns and Practices in C#. They are in chapter 28. It's only 10 pages, so you've got no excuse to read through them. So we've now got some techniques to resolve problems to do with these dependencies, but with great power comes great responsibility, and you may go too far. So here's another thing that I see quite often. We have a bunch of different features. One is products that needs this custom link provider, and we've got some other modules who don't need it. So now we've got a custom link provider that's been pushed down to the foundation layer, but only one feature module uses it. This is what I refer to as the unearned foundation status. Basically, it's a foundation module that only has one dependent feature, and that's adding complexity for the sake of it. People who come look at this code in the future will wonder why we pushed this logic down to the foundation. Foundation code really needs to be earned, so it's a privilege, and you really need at least 2 feature modules that depend on every foundation module. So Donald Knuth, who's one of the godfathers of computer science, said that premature optimization is the root of all evil. And I think this is a perfect example of that. Incidentally, Kent Beck also introduced a code smell named speculative generality, and I think this fits pretty well there too. So that's it. I've introduced a number of different Helix smells here. We had the Habitat Cargo Cult, where developers just blindly follow the look and feel of Habitat without really understanding the Helix principles. We had the Fat Foundation, which pushed more and more logic into the foundation layer, making it more inflexible. We had the Fat Project, which introduced logic into the project layer, meaning that became inflexible too. We had the Unstable Foundation, which means that foundation modules change frequently and have the potential to introduce bugs throughout your system. We also had the Unearned Foundation Status module, which is where a foundation module doesn't really deserve that status. So there are many more, believe me, and I could have gone on and on. Hopefully this has given you some tools to identify these smells when they arise, and maybe some techniques to overcome them before they get out of hand. So, thank you for listening. I really like feedback, so you can get hold of me at 20go to10 on Twitter. And if you want to learn more about this subject, take a look at sitecoreskills.blogspot.com. Thanks.